In this video, we'll export NC code. After completing this step, you'll be able to generate NC code and create an NC program. In Fusion 360, we want to carry on with our CAD/CAM milling dataset 1 verify and our CAD/CAM lathe dataset 1 verify. At this point, we want to talk about getting all the work that we've done out of Fusion and into G code so a machine can read it. We're going to focus on this process for our milling part, but the process is the same for our lathe part as well. The first thing that I'm going to do is minimize the models folder as well as my named views, and for right now I'm going to focus on op1 and op2. Whenever we're generating code, we can do this in two different ways in Fusion 360. We can go to Actions to select Post Process, which can also be found in our right-click menu, or we can create what's called an NC program. When we go to our Setup dropdown, we have Create NC Program. This allows us to create an NC program based on the capabilities of our machine and the operations that we want to export. In this case, we want to make sure that we pick the correct machine and we set all the settings that are required for our specific machine, as well as the operations that we want to machine. At this point, we're going to use the name number at 1001 and CAD/CAM 1 as the NC comment. I want to note that as we go down, we have the option to open the file in an editor, so we're going to go ahead and check that. And also note that you can post it directly to Fusion Teams. That'll allow you to save a local copy of the NC file as well as one inside of your data panel. Next, our post configuration. We can determine where this is going to come from. Our system, personal in the cloud, personal local, or we can browse for other post configurations. We're going to use system so that way everybody has the same access to these same posts. But also note there's a hyperlink where you can search for posts on our Autodesk HSM post library. I'm going to go to Capabilities and select Milling. This changes my post properties on the right-hand side and also limits me to looking at only milling post processors. We're going to scroll down until we get to Haas Automation. Once we find Haas Automation, this is now going to limit us a bit further. Only the posts that are available under the Haas Automation milling will be viewed. Inside of here, there are many different types of Haas post processors that are already loaded into the system. We have a pre-NGC or pre-next-gen controller. We have some next-gen controller posts that include things like inspect surface. And we have this one here that's called Haas Next Gen. We're going to go ahead and select this one here. Note on the right-hand side in Group 1, it says has A, B, and C axis rotary. These are all going to be no since we're dealing with a 3-axis machine. But note that because it's specific to the Haas Next Gen controller, it also shows things like our dynamic work offset and TCPC programming. That's tool center point control, and it's available on Haas Next Gen controllers. We can also scroll down in this list and activate any additional options that we might want. For example, we have default coolant pressure. We can also set it to low, normal, or high if that's available on your machine, whether or not you want to use a chip transport at the start of your program, and a couple other options as we scroll down that'll be applicable to the post that you selected. As we go through here, the last thing that I want to set is this option called Show Notes. Next, we want to go to our operations. NC Program is helpful because it allows us to select multiple setups and multiple operations. If we wanted to machine the top and the bottom of this part at the same time, this is obviously not possible on a single part, but if you were machining multiple parts, you could have 2 setups inside the machine and go through and save on tool changes, machining both at the same time. Ours are set up with the same work offset, so this is not going to work. But we can select OK instead of Post, and we can go back and make changes to the setup. In Op1, we're going to right-click and select Edit, go to Post Process, and we're going to set our WCS offset to 1. Then in Op2, we're going to right-click and edit. We're going to go to our post process, and we're going to set our WCS offset to 2, which will represent G55 in our Haas controller. Notice now our NC program says it's out of date. When we go in and edit, notice that the work offset is 1 for certain operations, and then we have 2 for a couple more, and it goes back to 1. This is because reorder to minimize tool changes is turned on. If we deselect that, it'll order them based on the operations as we define them. So this can be handy, especially if you want to spend time using the same tool without tool changes and machine various areas of multiple parts. I'm going to select Reorder and once again select OK. Once we're ready to post, we can right-click and select the option to post process. It's giving us a prompt telling us that we're using multiple setups with different WCSs, and it has to be customized to handle that. In our case, we're going to say OK, and I'm going to overwrite 1001.nc that's saved in my local temp folder. This is going to open up for me in Visual Studio Code. If you haven't defined any text editors or any NC editors inside of your Fusion 360 environment, then it's going to open up in either a Notepad or Visual Studio Code, similar for you as well. As we're inside of here, you'll note that we have our program, we have our comment for the program, and then we have information about things like the tools as we get into our different operations. When we get started, you can see we're referencing G54 or that WCS offset of 1. If we use Control F to look for another reference, we can search for G55. This is going to bring us to our 2D adaptive, which is in our second setup or our Op2. We can look for the next one if there's another reference to it, or we can go back and we can take a look at all of the G54 references. You can see here there are 5 different G54 references: the 2D contours, the drilling, the tapping, and then ultimately it goes back to the original facing. One great thing about these NC programs, again, is that we can go in and determine whether or not we want to post everything. And even within inside of Op1, we can determine if we want to have our drilling operations or if we need to save that at a later time. We could also use this to exclude certain operations based on tool availability or order of operations. I'm going to leave all of Op1 inside of here, and I'm going to select OK. And then I want to save the CAD-CAM milling dataset before moving on to our CAD-CAM lathe dataset. Once again, the process is exactly the same. We're going to go into Setup and create an NC program. This time we're using the program number 6001 with CAD-CAM turning 1. And this time, instead of milling, we're looking at turning. Once again, we're going to go to Haas Automation, but you can take a look at any post-processors that you might be using. Once we find Haas, we're going to search for a specific machine, in this case, an ST10. Once we've figured out which machine we're using, we can configure any post properties that are necessary. For example, if you're using an air clean chucks, if you have a chip conveyor, or if you're using a secondary spindle or C-axis. Once we've defined all of our post properties, we can go into operations and we can take a look at everything that's being posted. From here, we can select OK, or we can post the code. If I right-click, I can also post process from here and view the code. Once again, it looks very similar with our program name and number at the top. We have our comment, and then we get into our operations. We have facing, we have profile roughing, profile finishing, and as we go down the list, you can see that we end up with multiple operations: our single groove, our drilling, our tapping, our boring. All these different operations happen exactly as they were defined inside of our CNC program. As we're looking through the code, it's always important to validate the outputs based on your specific machine. For example, you want to check your values for Z movements and for X movements to make sure they're within the range of your machine and to make sure that they are as expected. For our part, we're going to go ahead and make sure that everything is saved, and then we can move on to the next step.